called deploy TS. As you remember, to deploy the contract, we need to calculate the future address of the contract. We compose an initial state of the contract, the code and initial data. We compose a message that will carry the initial state, and we send the composed message to the future address of the contract on blockchain. So here's what our deploy script will look like before we actually send the deploy message. So let me create the deploy TS file. So we are going to have a async function again called deploy script. And we are executing this async function. And here is the first part of our code that does exactly the first step. So we are calculating the future address of our contract. So we need to import important primitives. We import the cell class. We need to import our code. As you remember, we have it in our main build.js file, build.ts, from build. Main compile JSON. And we'll also learn about new class, new interface type. We need to import begin cell. And we need to import function store state init. And of course, contract address. So we have all imports ready. And let's learn a little more about what happens here. So we already familiar with all the types here except the state init, I guess, and store state init function. So store state init is provided by TONCore, and it helps us to actually create a cell that would have state init inside of it. And the state init itself, it's just a few parameters and some data that are going to be the initial state of the contract. That's why I call it state init. For now, it's important to know only about the code and data that is inside there, but we will see a bit later what else could be consistent there. So an important concept that is used here with state init, and we will have to learn about it, is builder. So builder is basically the functionality that helps us to build a cell. So as you can see in this code, we are creating a builder with function begin cell. So function begin cell is returning a builder. And then we use function store state init that is actually accepting state init object. So as you can see, the state init object is just a, let's say, TypeScript object with certain data. And the most important for us now is the code and initial data of the contract. And basically, this function is accepting state init object and returning builder. So we also have to provide a builder for the new cell. So we basically just execute this builder with this function with this builder. And the result of that is going to be obviously updated builder that we just opened here. So the only thing we need to do to get the finalized cell is actually end cell. So end cell is executing on builder and it's finalizing it into a complete cell. And then we use function contract address to calculate this address of the contract. So we compose the cell with initial state, and then we calculated the address, the future address. It's not dependent things, but this is something that we will need for next steps. We could achieve the same results by manually constructing the cell. So, as you know, we already, as you learned the concept of begin cell that is returning builder, we could manually go bit by bit and actually store data according to the supposed structure. So you can learn about this in the documentation, but I'm just showing you as an example that TypeScript libraries, TONCore, like there is more libraries like that, they're simply there to actually help you to get away from the very low level things like composing the cell, because this cell is composed quite often, and you will not need to do this manually every time. Very often you will compose the cells by yourself, but this is going to be your custom cells where you define the structure, and then your contract knows how to read it because you programmed it, right? But this moment, so basically you see that there is 1 bit for split depth. So these things are not even at the moment important for you because you don't want to get lost in these primitives. But here is like important that we actually put the cells, we kind of put the references to another cell. So in one cell, we can have some information as bits or some references to other cells. So it results as a tree of cells. You probably heard of that in first chapters. Okay, so I'm going to remove this thing because we're not going to use that low level, but this part is just doing just the same thing. So in order to send a message, we are going to need the Sandbox wallet that you've installed in the beginning. Sandbox has a cool API that enables deep linking into the wallet and TonHub as well. So meaning that we could compose a link that would have all the parameters needed to send a message. Then we open this link on our mobile and it will redirect us inside of the app and actually request a transaction. So we will have to confirm the transaction of sending this amount with certain data. And next step, what we're going to do, we're going to compose this kind of link, then create a QR code out of it, and then show it on the terminal. So we could scan it with our mobile. So we're going to install a few more libraries, especially if, one important for now is the query string, because imagine we have code and data stored inside of the initial state cell. So we have a whole cell that we will need to stringify into the base64 format. So basically we'll have the amount of money that need to be sent because it costs money to deploy contract. On testnet, obviously this money are not worth anything, but in real life you will need to send some money, some coins. So you would basically put the amount, message, and optionally you could put the initial state of something. So this transaction would mean a deploy of the contract. Let's install another library that is going to help us to show QR code in terminal. So we would pack this link into a QR code so we could scan it from our mobile. So with help of those two libraries, we are actually forming a URL. First, we need to import them. Also, we need to import the 2nano, and we need to import the QR code library. So now we're good to go, but let's have a look here. So we could also send much less money because the whole 1 TON coin would be too much for deploy contract, unless you want this contract to be deployed and have some extra money there. But we'll put there just enough to deploy it and have a little bit for the future costs. So basically, we're using this deep linking for TonHub. TonHub and Sandbox, don't get confused with that. It is the same application, but Sandbox is for testnet. So we are using subdomain test to actually form this link. So here we put the address, future address of the contract, and we also put the message, we put the amount, we put the init state, and as you can see, we are actually taking the cell, we put it as a body of cells, we serialize it to the body of cell, and then we actually stringify it in the base64 format. And then we are just packing this all into a QR code. So I'm going to save it. So just like we did in the previous lessons, why don't we just add some informative console logs so our script would make more sense while it's running. We would know the state of it. So we put the deploy script as running when it starts, and then let's put some console logs after we know the address, the future address of the contract. So we say, this is the address, and please scan the QR code below to deploy the contract. So let's go to package.json and create a new script called deploy, obviously. And we are going to, again, compile it just to make sure that no changes are actually lost. And we will run the scripts, deploy TypeScript, and run it with TypeScript node. Great. So now we can easily run yarn deploy.